Hello everyone. Welcome to another exciting lesson on multiplexers. And today I'll be discussing the 16 to 1 multiplexer, which is an essential digital circuit used in many systems. Let's do a short recap on what a multiplexer is. So a multiplexer or MUX is a combinational circuit that takes multiple input signals and selects one to pass to the output. So think of it as a digital switch. So based on the control input, it chooses which input to route to the output. Alright, so multiplexers are widely used in data routing, communication systems, arithmetic logic unit, and signal control circuit. Right. So the 16 to 1 multiplexer has 16 data input lines labeled I0 to I15. It has 4 select lines labeled S3 to S0, and it has one output, which is the Y. So it has one output line, which is the Y. Now the select lines determine which one of the 16 inputs is routed to the output. So in general, for 2 to the power n inputs, you are going to need n select lines. Right. So since we have 2 to the power 4 is equals to 16, we need 4 select lines to select from 16 inputs. Right, so this is the truth table of the 16 to 1 multiplexer. So each combination of the 4 select lines, that's from S3 to S0, corresponds to one input being selected. So for example, when the select lines are 0 0 0 0, the input I0 is selected. When the select lines are 0 0 0 1, the input I1 is selected, right? And so on and so forth. So the output Y equals the input line addressed by the select bits, right? Now let's look at the logic equation for a 16 to 1 multiplexer. So the output Y is given by a long sum of products, right? So it means you have to put all these together to form the sum of product. So it means that for each possible select combination, you are going to create an AND gate between the appropriate select input and the corresponding data input. So and then all these terms are going to be combined using an OR gate, right? So the MUX output equals the value of one input depending on which select lines are active. So for example, for input our output I0, our input is going to be S3 complement and S2 complement and S1 complement and S0 complement and I0, right? So we are going to need 5 input AND gate, right? So the 0 is our complemented form, and then our 1 is the true form, right? So let's try for output I1. So for I1, we are going to have I1 and input I1 and S3 complement, S2 complement, S1 complement, and S0. Right, for I2, we are going to have I2 and S3 complement, S2 complement, S1 and S0 complement. Alright, so for the circuit design, we are going to need 4 select lines. So we have our 4 select lines here. So this is our 4 select lines, right? And we are going to need 16 AND gate. So we have our 16 AND gate here, right? So we have our 16 AND gate. So for the select line, we can get it from here. So this is how we build our select line. And then for an AND gate, we can take it from here. So this is our AND gate. So we just pick 4 select lines and then 16 AND gate, and then we are going to need one OR gate, so for the OR gate we can pick it from here and then we place it here. Now we used, because we have 16 AND gates, we are going to have a 16 input OR gate. So all we did was change the input to 16, right? So that is what we used to build our OR gate here. And then this is our output, so we use this to build our output. All right, and then we connected all our AND gates to the OR gate. So this one will correspond to I0 connected to this I1, I2, I3, I4, I5, and so on up to I15. All right, and finally we are also going to need the NOT gate to generate the complemented select lines where needed, right? Right, so as we said, each AND gate is activated only when its select line combination matches, right? Letting just one input pass to the output. All right, so let's connect our AND gate using our truth table. All right. All right, so we are going to use the inverted one as our complemented form. So our complemented form is the 0. So anytime we see 0, that's our complemented form, and then the 1 will be our true form, right? So we are going to connect for each input, or for each AND gate. All right, so for the first one, we are going to have input I0. All right, so we have 0, 0, 0, 0. All right, and for the second input, we have 0001. So we have 0, 0, 0, 1. So we have our input here. All right, so for the third one, we have 0010. So we have 0, 0, 1, 0, and then our inputs. Alright, then for the fourth one, we have 0011. So we have 0, 0, 1, 1. Right, then we have our input here. Alright, so for the next one, we have for I4 we have 0100. So for I4 we have 0100. So we have 0, and then we have our input here. And then for the next one, for the I5, we have 0 1 0 1. So for I5 we have 0 1 0 1, and then we have our input. Alright, so for the next one, that's for I6, we have 0 1 1 0. So for I6 we have 0 1 1 0. So we have 0 1 1 0, and then we have our input here. Alright, so for I7 we have 0 1 1 1 0 1 1 1. Alright, so we have 0 1 1 and 1. Right, so with our input here. Alright, then we move to I8, where we have 1 0 0 0. So for I8 we have 1 0 0 0. So we have 1 0 0 0. Alright, so with our I8 input. Alright, then for I9 we have 1 0 0 1. So for I9 we have 1 0 0 1. So we have 1 0 0 1. Then with our input here. Alright, so for I10 we have 1 0 1 0. So for I10 we have 1 0 1 0. Alright, so we have our I10 input here. Alright, so for I11 we have 1 0 1 1. Right, so for I11 we have 1 0 1 1. So 1 0 1 1. Right, with our input here. Right, so I12 we have 1 1 0 0. So for I12 we have 1 1 1 1 0 0 with our input here. Alright, for I13 we have 1 1 0 1. I13 we have 1 1 0 1, and then our input here. Alright, then for I14 we have 1 1 1 0. I14 we have 1 1 1 0. So we have 1 1 1 0, and then finally for I15, we have 1 1 1 1. So we have 1 1 1 1, right? So we have our input. Alright, final input here. Alright, so finally our 16 to 1 multiplexer is ready. So let's implement it and let's see how it works. Alright, so go here, simulate. Alright, now now if the select line is 0 0 0 0, our input 1 will be active and the rest will not be active. Right, so if our input 0 0 0 1, if our select line is 0 0 0 1, then only input 2 will be active. If our select line is 0 0 1 0, then it means that only input 3 will be active. And if our select line 0 0 1 1, if our select line is 0 0 1 1, then it means that only input I3 will be active. So this is input I3 and only input I3 is active. And finally, if our select line is 1 1 1 1, so let's do 1 1 1 1, then only our input 15 will be active. Alright, so this is basically how to build a 16 to 1 multiplexer. Alright, so we can also implement the 16 to 1 multiplexer using integrated circuit, right? So a popular integrated circuit is the 74150, which has 16 data inputs, 4 select inputs, and then 1 output, right? Alright, now the 16 to 1 multiplexer selects 1 out of 16 input lines based on 4 control signals. So only the selected input is passed to the single output, right? So we can implement it using the logic gate as you have seen here, or you can also use the IC like the 74150. Now the 16 or the multiplexer or the 16 to 1 multiplexer is widely used in data electronics for routing data, selecting signals, or controlling operations, right? So thank you for your attention, and I'll see you guys next time. Right, bye.